In this video, I will be discussing one of the new improvements made in ObserVIEW 2024 related to STAG, Sine Tracking Acceleration Generation, which is our sine-on-random test development tool. This is specifically related to stationary RPM environments. In this case, I have a Honda gas-powered engine for a ventilation fan, and it runs at a fixed RPM depending on the throttle level. So to start, I need to figure out what that RPM is. I have a recorded segment of the data at full throttle. I can create an FFT, increase my number of analysis lines so I get a very, very precise measurement as to where this peak is. And I can see that it is at 29.531 hertz. So now to convert that into RPM and create a RPM channel, a TAC channel that I can reference, I click on my waveform graph, go to Math, 29.531 RPS, revolutions per second, and plot that on my graph. 29.531, 29.531. Then I can go through the normal STAG process. So I can go to Order Analysis, click Add TAC Spectrogram. Once my TAC spectrogram is there, I can click on STAG. Once I have the STAG window open, I can pick the channels I'm interested in. In this case, I'm only going to look at channels 4 and 7, which are my Z-axis channels. Those were going outward from the engine. I can scroll through my FDS parameters. I could do test acceleration here. Because I'm not sweeping, the number of sweeps don't really matter or apply. I can look at my FDS parameters. In this case, we're going to go from 5 to 1000 hertz. And my filter settings, 5 hertz, 20%, 1 hertz. Those should work. I can now click Add Top Orders. And the software is automatically going to go through and find some of the top orders. So here I have order 2, 3, 4. I'm pretty confident that we're just going to get rid of some of these high orders. And we're going to start at 0.5. I can manually insert these. Let's look at 5, or 4.5, 5, 6. And I can do this for a variety of orders. Now highlight all of them and look to see which ones are of interest. So if I reanalyze this data a little bit, maybe get rid of my start and end points, which may have some oddities, I can double check the software. So order half really isn't very useful. Again, select all. So 1, 1.5, not very useful. I manually added these just to show this process. So order number 2 looks really good. 1, yeah, 2, 3. One, 2, 3, 4, 5, 6, 7, 8, 9. So there's 11 orders. Let's see what that looks like in comparison to our random data. So I can export, click Save. As I skim this data, I can see that there's not a very sharp, narrow peak left in this software. So that is a good sign, meaning that I am picking out the correct tones. We can look at the table tab and see if we have any tones that are very, very close to our random. You can see here 1, 2, 3, 4, this fifth tone at right around 133 hertz. If I add a cursor here, $193 and 223. So 132, 193, 224. So 133, this one, those are some of these very, very low ones. It's going to be this one. So 4.5, 6.5, and 7.5. Those three are there, but because they're buried in the random, there's really no value in having them in our test definition. And let's just add 8 in here because these are all the main orders. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So that's our first 9 orders. Click Export to Vibration View. We can look at our test again. See that everything looks really good here. Look at our table. None of these are exceptionally close other than this order right here, which is going to be number 8, the one that was automatically left off. But now that we have that, I can click Save As. Save it. I can open the file in Vibration View, which is connected to my controller. And if I wanted to, I could turn on my small shaker. And start my test. Again, you can see that this tone is relatively close to the random. It could give us problems. Once we get the test up to level, a way to get around that is in our sine-on-random tabs, make this very narrow, this tracking filter. The more narrow we make that, the less variability there will be, the less random contribution there is to that measured signal. So as we get up to full level, we can really narrow that down, and it will make that tone much, much more stable. And now, yeah, I messed with settings, so things aborted. If I wanted to, my abort is on that tone 8. So just to see, I can go to my Sine-on-Random tab, and I could remove that there, or in the Schedule tab, I can just remove tone 8. Again, it's so close to the random that the sine tone really isn't contributing much value. Let's just open up our tracking filters a little bit here. We'll let this test come up to level. And just like that, I have created a sine-on-random test from recorded field data that did not have a tachometer reference, specifically for data where there is a stationary RPM signal. If anyone has questions, wants to do this, please let us know. This would apply to a wide range of potential tests. We've done this with compressors, with generators, with small engines, with larger engines, jet engines, and everything and anything in between. Feel free to reach out to VR Sales or support@vibrationresearch.com if you have any questions. Thank you.